Welcome to this presentation in which I will try to clear the doubt of one of our viewers related to the don't care in K-map. So the function which I took was f having the min terms 2, 3, 4, 5 and the don't care 6, 7. I in first case solved the K-map without using the don't cares, as you can see here, and I found out that the function is equal to A XOR B. Then in the next case I took the don't cares, which you can see here, cross the 2 cross as 1 because we are solving it as a min term, and in that case I found out the function to be B or A. So the doubt asked by him is that how this A XOR B is equal to A or B, because both of them is having the different truth tables. So I'm just going to explain what it is actually. Let's see what he has written. He is Rodolfo Lozano. The first function is A exclusive or B. Okay, the second function is A or B. Are they the same answer? The truth table for both tells me no. Okay, definitely you're right. The truth table of A XOR B is not equal to A or B, but we have to check for this particular case. Okay, we cannot check for the just simple A XOR B is equal to A or B. We are not going to check it by what we have studied, but we will check it by the function that I have used in the example. So the function was f, a, b, c were the variables, and summation m. The min terms are 2, 3, 4 and 5, and the don't cares are 6 and 7. So now I will make the truth table. So let's make the truth table. A is your MSB, C is your LSB, and F is your output. So as there are 3 variables, we are having 8 possible combinations. So let me write it down. This is actually a very basic thing, but at the same time most of the people ignore these things. So I'm grateful that he asked this doubt so that I got a chance to make a lecture on it. So this is our possible conditions. Now as you can see that the min terms are 2, 3, 4, 5, which means that for this is your M0, M1 all the way to M7, and by this it means that M2 is 1, M3 is 1, M4 is 1, M5 is 1, rest of them are 0, and the last 2 are don't cares. Okay, so let's see. In this first case I didn't actually took the don't care, so we will try to do the same thing in the truth table also. We will not consider this don't cares. So the function is true when the number of 1 in A and B is odd. As you can see that 0, 1 only a single 1, 0, 1 only a single 1, in this also. So as you know that XOR is odd ones detector, and in AB the output is true when the number of ones are odd. You can see that. Therefore I can write for this case the function f is equal to A XOR B. Okay, I think it is clear for you. And now let's just take this cross as 1, this don't cares as 1, as I did in my K-map. So these 2 are now 1. So this is 1 when B is 1, this is 1 when B is 1, and for all these ones A is 1. So I can say that for this particular case, the function f is equal to a or b. Okay, let's see it again. 0 1, a or b is 1. 0 1, a or b is 1. 1 0, it's again 1, and 1 0, it's 1. And for the last two cases, a and b both are 1, so definitely the output is 1. So I can write it like f is equal to a or b. So the same thing we did in our K-map, and by doing that, definitely we are having a single 2-input OR gate for the same function, and without the don't cares, we are having something like a complement b or b complement a. So the number of gate is increased, and hence the speed is decreased, and also the power dissipation is increased, and so many drawbacks. So I think now your doubt is clear, and that is what we have to do. We have to check for the function that is given actually in the question, instead of just thinking that XOR is not equal to OR. So thank you.